So for derivatives of trigonometric functions, so I think that you have to take note the different types of derivatives, because later on when we go to your integrals, that that would be just the reverse um, formula of your derivative. So for example, again, in our previous discussion, so let's say we have let's say we have the derivative of x, di ba? Or let's say x squared. So derivative for this one is 2x. So what will happen in your integral is that we're going to integrate 2x to bring back x squared. So that's why it's important to remember as well your derivatives, because again, the way to verify the answer for your integrals would be using the derivatives. Okay, so for the derivative of the sine function, so derivative of sine function is just cosine. So in other way of writing this one, this should be d over dx. Then let's say the sine x is equal to cosine x. So other formula as well will present us with a formula of um, sine u du is equal to so it would be cosine u and then du. So in other terms, so you have to derive first the sine function sine u, which would give you cosine u. Then you derive again du, which gives us the du. So I think the purpose of this one is, if let's say your angle is, let's say this angle is not totally just the x variable, but let's say you're going to have sine 3x. So let's say nasa coefficient, diba? The angle has a coefficient. So what you need to do is you integrate first sine, then in I mean derive first sine, then derive next the angle, which is 3x. So if you're going to have the derivative of sine 3x, so derivative of sine 3x, so this would give us again derive first sine. So this would give us cosine, I'm sorry, this would give us cosine 3x, and then again derive next the angle. Okay, so the final answer for this one would be 3 cosine 3x. So muna siya kanang siya diretso na siya cosine x, diba? Because if you derive x angle, it's just equal to 1, diba? That's why it is still cosine x. So what if you have a numerical coefficient in your angle? So muna, that's the time that you're going to multiply it again with the derivative of the angle. So let's say again, another example would be, let's say sine 9x, yeah. So derivative of sine 9x would be cosine 9x times 9. So the final answer would be 9 cosine 9x. Okay, so I think that's what you have to remember with the angles of your trigonometric functions. So you have to derive the angle. So derive the function, then derive the angle. Okay. So for cosine is, so if you look at the formula, it's just the, so for sine, it's cosine, diba? So if you try to reverse it, if you try to get the derivative of cosine, it would give you a negative sine angle. So again, yung difference is this one, negative sine angle. So again, that one's just pretty simple. So for example, you're going to give a numerical value sa angle sa cosine ninyo. Let's say cosine x over 2. Diba? So getting the derivative of cosine x over 2. So again, derive first the angle. I mean the trigonometric function, which would give us negative sine x over 2. Then next is derive the coefficient. So the coefficient is 1/2, diba? So times 1/2. So the final answer would be negative 1/2 sine x all over 2. Okay, so later on we're going to have complicated examples um, which deals with different types of techniques of derivatives, which was discussed last meeting, such as the product rule and the quotient rule. So we're going to have those types of examples later after we discuss all the um, derivatives. So I just discussed this one because I think important sa niya ang mga coefficients sa inyong angle. Okay, so again, there are many ways on how to present your coefficients. So meaning the coefficients are the numerical values, di ba? Anong mga dili letters. So muna sila. Okay, so tangent is you're going to have it as secant squared. Okay, so secant squared. The derivative of tangent squared is secant squared. So again, if you have a numerical value for the angle, so what you're going to do is you derive first a whole function, triangle function, and then derive next the angle. Okay, so cotangent is you're going to have negative cosecant squared x. So that will be the derivative. And then secant x is equals to secant x tangent x. So I think you don't have to worry lang siguro. I'll just let you have the unopened notes during the exam. Okay, para at least katabang-tabang sa ninyo. Then dx is cosecant x equals negative cosecant x cotangent x. And then that would be it for the trigo functions. So I think ang inyong challenge ani is, let's say for example, you're going to get the derivative of let's say sine x and then tangent x. Diba? So it's a product rule, which is what I talked about last meeting. So again, you may set this one as your u and v, diba? At ang formula nga u dv equals v du. So before we go to the next, let's try to solve this one first. Diba? This one is u. Dili maklaro, no? Okay, so let's say this one is your u. And then the other one is your v. Let's say this one is V. So the formula would be U dV plus V du if it's product rule. So U dV. So let's try creating the colors lang para U dV plus ako lang i-color dana para so U dV plus V du. Okay? Para makita nyo ninyo where you're going to get the different parts in your derivative. So first is U, so that would be sine x. Then multiplied by the derivative of V. So derivative of V is secant squared x. So again, if you know the formula, you can answer this directly. Plus V du, so that would be sine, let's say tangent x times sine x. Let's say that would be cosine x because you're going to have the derivative of sine x. Okay. So again, for the different parts, of course, you can just follow through the different parts. You may verify this one using your, let's say, notes later, or let's say your book, or any reference you can find in the internet. Okay, so if you're going to finalize the answer, so take note that you also have to try to be familiar with the different components of your trigo function. So let's say tangent x can be further classified as sine x over cosine x, diba? And then it's being multiplied with cosine x. So meaning you can cancel out cosine x, and what's left on the right side term would be sine x only. Okay, so your final answer would be sine x times secant squared x plus sine x. Or you may try to factor out your answer also. That would be sine x, then parenthesis, secant squared x plus 1. Okay? So that would be your final answer. So again, try to incorporate the different formulas that that I have discussed last meeting, especially for quotient and product rule, because I think that would be the recurring problems in the midterm exam. Okay, so atong midterm exam, 1 hour lang para, let's say 1 hour and a half to give you times and also. Okay, so let's try to go to the next what I said. Okay, so let's go to the differentiation of our natural exponential function. So again, exponential functions are the e to the power of something, e raised to any exponent. So let's say e to the power of x. That's what we call as exponential function, natural exponential function. So I think you can find this one in your calculator, diba? Letter E, yeah. Then I box it afterwards, and that's the natural exponential function. Okay, so this is again, this one is only short because we're going to try to just um, get the formula of this particular derivative. So before that, let's try to understand again what natural exponential function is. So natural exponential function is the inverse of the natural logarithmic function. So probably you'll get confused by this statement, but if you try to define it in mathematical terms, this one is natural exponential function. This one is natural logarithm, ln of x, ln natural logarithm. So kaning log, that's not the okay. So again, it states that the exponential function is just the inverse of the natural logarithmic of the natural logarithmic function. So hindi ko siya important, but again, this is the definition. So also, please be reminded of the different theorems involving natural exponential functions. Oh, I think you have this one in your high school. Okay, so I think that's you have the different types of equivalents here. So if you have a to the x, you can try to make it in exponential function format. So this would give us e to the power of x ln a. So that's what the meaning. So that's the meaning of exp. Okay. So ln a to the power of x, this one. So you can bring down the power on the left side. That's why it's x ln of a. So e, um, so natural logarithm of e is equal to 1. Then exponential x. So again, you can try to write expx as e to the power of x. And then I think this one is important, the last one. So if it's e raised to a common, or rather a natural log, so it are concerned with your natural logarithm, rather not exponential function. So dili pa rin siya derivative, so these are just theorems. Okay, so for properties, so again, I think exponent na mga properties. So if you, diba, if you have the same base, you may add the exponent. Diba? Same base, then divide. So meaning you can have the division, diba? Then power to power rule, that would give you the multiplication aspect. Okay, so the next one would be the formula for the natural exponential function. So the formula states that if you have a natural exponential function, e to the power of u, the formula would be first, you copy first the exponential function presented. And the next step would be to get the derivative of the exponent, then multiplied by the equation. Let's say, for example, you're going to get the derivative of, let's say, e to the power of 2x. So again, the first step is to copy first the exponential function, e to the power of 2x. And the next is you derive the exponent, which is 2x, so that would give us only 2, di ba? So the final answer would be 2 times e raised to the power of 2x. Okay, so I think mura na siya ang special part about this particular problem. So let's have another one. So again, regardless of, let's say it's e to the power of x squared minus 1. Let's say muna siya yung exponent. So again, the first thing that you need to do is to try to copy first the given exponential function, because that is the first thing that you need to do. Then the second thing you need to do is to derive the exponent. So derivative of x squared minus 1, this would give us 2x minus 0, diba? So that's just 2x. So final answer would be 2x e raised to the x squared minus 1. So I think wala siyang special ano niya. Okay. So try looking at this example. So that's y equals e to the power of 1 over x squared. So again, getting the derivative. So again, since it's presented as y equals e to the power of 1 over x squared, so that's why the left hand side is dy over dx. Okay, so don't be confused by that term. Okay, so again, the first step is always to try to write the given exponential function. Then next is you get the derivative of the exponent, di ba? This one is coming from the exponent. So see, derivative of the exponent. Okay, so the exponent can be expressed as x to the power of -2, and then using the basic formula, di ba? Bring down the exponent, then -1, that will give you -3. And so this would be the final answer. Okay, so again, if you try to use the properties of your natural exponential function, you can break this one into two different parts, diba? Since you are adding two different portions, diba? So you may separate this one into two different components, and the equation simplifies into this portion here. So kung ano ma-simplify mo siya, so just try to look at the properties again, because this one would give you the x value only. Okay, so notice you're going to have two different types of functions here. So one is algebraic, which is the x value. The second one is your natural exponential function. So meaning you're going to use the product theorem of differentiation. Atong u dv plus v du. Okay, so I think that's what you need to observe here. So again, if it's multiplication of two different functions, or let's say multiplication of two terms, regardless of their type of function, so you have to use the product rule, itong basic rule, itong product. Yeah, if it's division, that would be quotient rule. So quotient, diba? I think more dyan na siya yung timanaan. Quotient rule is v du minus u dv over v squared. Na. Going to use the formula for your derivatives. Okay? So, kung tanaw nyo, di ba? This one is the product rule of differentiation. Okay? So, let's go to the last part, which is so this is the last part, which is your natural logarithm. So kanina, it's natural exponential. This one is natural logarithm. Okay, so for natural logarithm, the formula would be 1 over u times the derivative of the given function of the natural logarithm. Okay, so I think the other way to express this one is du over u. For Kwanday, katong exponential, the exponential derivative, you may express it as eu du. Ano? So get the function, then get this one is get the of the given base term, then copy it in the denominator. So for example, you're going to have ln of 2x. So again, the first thing that you need to do is to derive first, diba? Derive nasa numerator. So try writing a fraction, then get, so copy first the denominator 2x, and then the numerator is get the derivative of this one. So that's just 2, then cancel 2. So derivative of this one is 1 over x. Siya kadali, di ba? So let's try to make it complicated. Let's say ln of sine x. So pili siya na ha. Again, create a fraction bar. Copy first the given function of the logarithm in the denominator, sine x. And then derivative of sine x is cosine x. So cosine x over sine x would give you cotangent x. So that would be the final answer. So ano na siya? So let's say con siguro. Another example would be, let's say e raised to the power of cosine x. So again, copy first e raised to the power of cosine x. Diba? Then the numerator would be eu du. So e raised to the power of cosine x. Then get the derivative of u, which is negative sine x. So cancel out, cancel out. The answer would be negative sine x. Okay? So ano naman siya? So I'm just going to post different slides later. Okay, para na mo yung ma-review. But again, you can just try to search it online, especially for notes. Naradyo dito sa internet. Okay, so these are properties on logarithms. So it might be helpful later on when you try to simplify your logarithms. So murag high school kay siya, di ba? Kay it's coming from algebra jud. So I try to again explain this. So again, murag same format, di ba? So you try looking this example later. Ang iya is kuan lang jud siya. Iya lang gi-follow ang format sa formula given sa kaninga presentation. But again, you can just multiply the derivative ahead of time in the numerator because padung mangyapon siya dito, di ba? It will always give you in the value in the numerator. Okay, so notice that the derivative of this one is 6x. Derivative of this one is just 6. This one is 0, di ba? That's why it is not present anymore. So again, notice that the derivative of any function will just be multiplied in the numerator, so that's why it's here. Okay, so just try to review this one. I'm just going to post this one later, examples. And it would be redundant for me to keep on repeating the format of the given formula. Okay, so I think that would be it for the derivatives. So again, I won't be discussing the inverse trigo function and then also the hyperbolic trigonometric function. Okay, para dili na kayo siya daghan kayo for your midterm exam. Okay, so for your midterm exam, again, that will be on next Tuesday. So we'll start by 7:30 still and end up probably around siguro siguro. You want it this week para next week wala na mo midterm exam. Let's say on 7. Okay, total open notes bitaw, di ba? Hello? Wala may ganang violent reaction if I make it this week. Dapat tayo, di mo tubag, meaning this week di ay. So anyway, so basin niya, natuog pa mo balik. So I'll just announce the exam on Wednesday, but again, probably it would be this week or probably next Tuesday. Para at least you can enjoy your long weekend. Okay, so